Okay, so today we're going to dig into some fascinating stuff about magma.
Yeah, should be fun.
You bet. You sent over some really interesting stuff on this.
Hope you like it.
Definitely. We've got a scientific paper about a new discovery in East Africa.
Yeah.
And some info on a project in Iceland trying to use magma for energy.
That's right.
Is that even possible?
It is mind-blowing stuff, really. We'll be looking at how magma works naturally, but also how people are trying to harness its power to make, well, human power.
Okay, so let's start with East Africa, this
Yeah.
discovery. The paper mentions the Afar Depression. What is that?
So imagine a place, right, where the Earth's crust is literally being pulled apart.
Okay.
That's the Afar Depression. You've got 3 rifts converging there, like giant cracks in the Earth's surface.
Oh, wow.
It's like the Earth is letting off steam.
So a triple whammy of geological activity.
Basically.
But the paper mentions the crust is thicker than expected there. Shouldn't it be thinner if it's being pulled apart? I mean...
You'd think so, right? And that's what's puzzled geologists for so long. They look at this area, the Earth is splitting apart. But the crust is thick. It just didn't add up. Until recently, at least.
So what's the explanation?
Well, researchers have been using this really cool technology. It's called INSAR.
INSAR?
Basically, it's like having X-ray vision for the Earth.
Whoa.
But instead of X-rays, it uses radar, bounced off satellites.
Oh, wow. So spy tech for geologists. I like it.
Exactly.
So what did they find with this INSAR?
So they found these massive sheets of magma underground.
Really?
Yeah, they're called sills.
Sills.
Horizontal sheets. Imagine spreading jam on hot toast.
Okay.
It spreads out, right? These magma sills are kind of like that, pushing through the Earth's crust.
Okay, so what makes them so special?
The remarkable thing is, these sills, even when they're tens of kilometers apart,
Yeah.
they all inflated at the same time, like they were connected to the same pump, deep down in the Earth's mantle.
Mantle.
The layer below the crust. It's like a massive interconnected magma system, and we're only just starting to grasp it.
So this study's basically showing us how the Earth is put together.
In a way, yeah, it's more dynamic than we thought.
Yeah, definitely. What does this mean, big picture, though?
So it actually supports this theory, right? It's called magma-compensated thinning. The Earth's crust, it's trying to thin out, right, as the plates pull apart.
Right.
But the magma from deep down, it keeps pushing up, almost filling the gaps.
So it's like a battle between
No.
stretching and filling.
A constant battle, yeah.
Yeah.
And these sills, they weren't random. They clustered along a specific boundary, deep in the Earth. It's like the magma uses that boundary as a roadmap as it rises from the mantle.
So we've seen how magma works naturally. But what if we could get closer? That's where Iceland comes in, with this whole Krafla Magma Testbed thing. It sounds kind of sci-fi.
It's pretty wild, yeah. The Krafla Magma Testbed, KMT for sure. It's about as close as we can get to, poking a sleeping dragon.
Right. Except this dragon is molten rock. So I'm picturing, like, scientists in these heat-proof suits drilling into a volcano.
Yeah, it's a bit less dramatic than that in reality.
Oh.
But the challenges are very real. I mean, can you imagine the engineer?
Intense.
Temperatures that can melt metal, crazy pressures that could crush normal equipment. And then there's the magma itself. Not exactly easy to work with.
Yeah, I bet. I'm guessing regular drill bits aren't going to cut it.
Nope. This is where it gets interesting. KMT's really pushing the boundaries of what's possible. They're inventing new materials, advanced metal alloys, super ceramics, stuff that can handle those temperatures and pressures.
Wow, so it's like they're having to invent a whole new industrial revolution just to reach the magma.
Basically, yeah. And it's not even just about strength. Magma is incredibly corrosive, too. Eats through stuff. So they need sensors and instruments that can survive down there long enough to give us data, at least.
Makes sense. So is it safe, though? Are they going to accidentally cause an eruption?
It's definitely a risk, yeah. But not one they're taking lightly. They have whole teams monitoring every little change. Seismic activity, ground movement, you name it. Anything that could be a red flag.
So like volcano doctors, checking its vital signs.
That's a good way to put it. And they're really open about the risks. They're working with the locals, government agencies, everybody, to keep everyone informed and on board.
So the whole planet's watching, basically.
Yeah.
But what's the goal here? What are they hoping to get out of this magma? So we've talked about how and why they're doing this whole magma drilling thing, but what's the payoff? What are they hoping to learn by, sticking a thermometer into the Earth's furnace?
It's like this Right now, we're stuck studying volcanoes from the surface.
But
It's like
later.
trying to understand the ocean just by looking at the waves. KMT, though, that gives us a chance to actually go deeper.
I see.
See the forces driving those eruptions, understand how magma behaves at its source.
So it's about getting a front row seat to, like, how the planet works.
Exactly.
What could we do with that knowledge, though?
Well, for one, imagine predicting eruptions way more accurately.
Oh, wow.
We're talking about giving people living near volcanoes more time to escape, saving lives even.
Yeah, that'd be huge. But there's more, right?
Oh, yeah. Remember, geothermal energy? Iceland already gets a lot of power that way.
Right.
But this is next level. KMT could unlock a whole new scale of geothermal energy, maybe even enough for the whole world.
So magma, instead of being this destructive force, could actually be a source of clean energy.
Pretty much, yeah.
And it's incredible.
And that's not even mentioning the scientific discoveries. Studying magma this directly, we could learn how our planet formed, how the continents split, even about the possibility of life on other planets.
Okay, you've convinced me.
Yeah.
This KMT thing, it's not just about clean energy. It could rewrite what we know about the Earth, even beyond that.
It's really exciting stuff.
It really is. Thanks for diving deep into the world of magma with me. From those unexpected discoveries in East Africa to the incredible ambitions of KMT, magma, it's a powerful force.
For sure.
But with some careful study, some respect for its power, it could hold the key to a brighter future.
Couldn't have said it better myself. There's a whole universe of potential right under our feet.
Well, folks, there you have it. A glimpse into the fiery heart of our planet and the efforts to understand and harness the power of magma. Until next time, keep exploring and never stop questioning the world around you.